You're making a password that begins with 8 single-digit even numbers and then ends with 4 single-digit prime numbers. How many unique 12-digit passwords can you make considering these constraints? So let's start with the even numbers. So we're going to make 8 decisions here with 5 options per decision. So that is 5 to the 8th power. That's essentially what that is. So the reason why we have 5 options, by the way, is because 0 also counts. So 0, 2, 4, 6, 8 is 5 options. Now we need to talk about the prime single-digit numbers. If we were to keep going, we would certainly have 4 more decisions. So this is going to be to the 4th power, whatever the options are to the 4th power. So let's talk about the options. The number of single-digit prime numbers is actually 4. Why 4 though? Because 1 doesn't count, first of all. So we have 2, 3, 5, and then 7. Here are our prime numbers, our eligible prime numbers. So looking at the answer choices though, we can see they're all 10 base, so that's a problem. We have to simplify this. You should start by looking at this 4 and seeing that it's not simplified to its prime factor, 2 being the prime factor. So 2 squared is 4, so we could rewrite this as this. Still have 5 to the x power here. But what is 2 squared to the 4th power? Well, that's equal to 2 to the 8th power. Why? Because we multiply exponents when there's an exponent outside of another exponent. Now what are we left with here? We're left with 8 5s and 8 2s. Well, if for every 5 there's a 2, we could rewrite it as 5 times 2 times 5 times 2, 8 times. Well, every 5 times 2 is a 10. So what does that mean? That means there are 8 10s, making the answer